Hello. I was discussing Harrod-Domar model, and as I said, I picked up Domar to be treated first. And accordingly, I was just in the initial stage of discussing the Domar model. And in fact, we traversed some journey, of course, together, and we reached here, the equation number one, where we found that how an initial change in investment leads to this kind of a relation, which is very Keynesian type. And the second effect that investment creates in the economy is the capacity effect. And the capacity effect, according to Domer, it goes like this: that the capacity effect he takes as the kappa. It is the potential capacity for the economy, and he says that this capacity capital ratio is actually equal to a constant. In this case, I have taken rho. Now, let me explain this part a bit. If we just go to the next stage, you find that its capacity is actually equal to rho k. So, what does it in effect mean? It means that the investment has led to a kind of additional capacity building in the economy. And what kind of capacity it is all about? It is the capacity of churning out additional output in the economy, or I should say in a different way, that the economy is now potentially capable of churning out some additional production. And this is actually the kappa, and this kappa by k, that means the given stock of capital, this ratio is taken to be a fixed one, a constant one. So actually the capacity or the kappa depends on the constant value rho and the initial capital stock. So now we take the first differentiation of this relation with respect to t. So we find that d kappa by dt equal to rho dk by dt. The rho being constant, obviously it will remain as the coefficient. And this dk by dt is because the change in capital stock over time is actually nothing but investment. So we have the rho I. So d kappa by dt is actually equal to rho I. So this is our second equation. Now the third thing, very important, what Domar says, and in fact that makes Domar's model somewhat unique. He says that actually the economy needs a kind of a time path of investment at a certain rate, which eventually we'll find it's an exponential rate, so that, or I should say so much so that there is an equilibrium in the economy. Now, what kind of equilibrium Domar was talking about? Domar said that equilibrium should be between the income generation and the capacity creation. Now, this is a very fundamental point, and you should be doubly careful about that. What exactly Domar wanted to mean by this? Domar contemplated a kind of an equilibrium, or a kind of a continuous equilibrium in the economy, where there will be neither additional demand nor additional supply. So, I mean, there should not be any kind of either recessionary situation or kind of an inflationary situation. As I mean, neither inflation nor deflation should be the ideal setup in the economy, if, or rather, if and when we have a kind of an adjustment where the potential or the expected investment path will generate a continuous equilibrium between the total capacity created by the change in the investment and the additional income that is generated. Now, how is that actually? Because the income generated will go to the demand side and the capacity creation will go to the supply side. So the additional demand and additional supply shall always be equal, thereby making the equilibrium so seamless. And in order to maintain that equilibrium, the economy requires certain rate of investment, which is actually the required rate of investment, what Domar was talking about. We'll find that actually our final target is to arrive at that time path of investment. This is the solution of the model actually. So this is where we are. So the third premise, we find that capacity creation is equal to income generation. Now capacity creation is actually what? The second equation gives us that, means d kappa by dt should be equal to what? Income generation. So income generation means dy by dt. So this should happen. Let's level it as relation number 3. Now if I replace 1 and 2 in 3, then what I find? If I replace 1 and 2 in 3, then I find on the left hand side I find d kappa by dt means it will be rho I, and for the right hand side, and let me take the right hand side first on the left, then dy by dt we found that this was 1 by small s into di by dt, and this should be equal to rho I. So this is the equilibrating situation where you find that the capacity side is just equal to the income generation side. So a simple manipulation should tell us that this is actually this is 1 by I into di by dt equal to rho s, and if I make further simplification of this relation, just break it down to the next step, then we may have something like this: 1 by I di equal to rho s dt. Now if I now integrate both sides, because ultimately I have to find out the investment time path for the economy, and which should give the assurance for an equilibrium throughout to be maintained as the investment goes on at the required rate. So if we just consider the first order differential equation, so just integrating both sides, we have di equal to rho s dt. So left side will give us log I, right side will give us rho s t, and of course there will be a constant of integration c. So I want I mean the I should be the free one, so the I is equal to e to the power rho st plus c. Now this I is actually a function of t, not to forget that this I is actually a function of t, and this is what? E to the power c into e to the power rho st. Now what I shall do, let me introduce a foreign element in the model, capital A, and thereby let us rewrite this equation as it equal to a e to the power rho st, where a is equal to e to the power c. Now this is a general kind of a solution of a differential equation that we have arrived at, which gives us a time path, and obviously we have an exponential results because it is e to the power rho st. But we have, to get a particular solution, obviously we have to get rid of a, and this we can do by applying some initial condition. Now put t equal to 0, means let's think about some reference time frame where t is 0. Let's take the initial time when our discussion starts, then the time is 0. In that case, what follows? I naught equal to a e to the power rho s into 0. So obviously this e to the power rho s 0 means 0, and see rho s 0 is 0, so e to the power 0 is 1, so we will be left with I naught equal to a. Therefore the specific solution is it equal to, this a is now I naught, So we now endogenize it actually. I t equal to I naught into e to the power rho s t. This is suppose, I think this is equation number 4. And this equation 4 is the desired or required time path of investment that we may conceive of in the Domar model. So much so that if the economy maintains a growth rate of rho s actually is the growth rate, and which is the required growth rate. Now it is required in what sense? It is required in that sense that if the economy can maintain this growth rate, then the economy will always experience an equalization of its demand and supply. I mean, in terms of the major macroeconomic indicators, say in the Keynesian sense is aggregate demand and aggregate supply. As a result, the economy will continue to be in the state of equilibrium. So this is the required rate of growth, and the required rate of growth is, as I said, required rate of growth. I mean, growth of what? Growth of national income, of course. Our Y is national income, and this is different from GDP, because GDP is a concept which in Domar's time was not very much was not in use actually. National income was the more popular type of a concept. So Domar used the word national income in his paper. So this is the required rate of growth of national income, and which is, as I said, which is rho s. Now, what is s? S is the marginal propensity to save. And what is rho? What was the rho actually? Rho, if you can recall, in my last class, the rho was actually the capacity capital ratio. Rho was this. It was kappa by k was rho. By the way, this kappa, this rho, these are all the Greek letters. This kappa, this is the English spelling kappa, and this is RHO, rho. Very common kind of denominations we use. So this kappa by k is the rho, and rho is a constant. So Domar considers a constant capacity capital ratio. Now, a lot of questions may be asked regarding such very restrictive assumptions. We'll come to those things, but not in this class actually. After we wind up the entire discussion. So over the last two classes, the last one and this one, we have been successful in arriving at the time path of investment. That if this time path of investment could be maintained in an economy, then one thing is for sure, that the economy, according to Domar, according to this particular paper, according to this whole discussion, that the economy will continue to be in equilibrium. So with that actually, I have to say bye-bye to you in this particular class. We will continue, of course. We'll continue because we'll require one more class for Domar, and only after that I'll go to Harrod. So maybe 2 or 3 more classes I'll require for covering in entirety the Harrod-Domar growth model. In the meantime, I'll request you to go through the things, and particularly to go through the paper that, as I promised, I'll be sharing with you before you actually get to watch this video. So just will be very interested and curious to know your feedback about the classes. Just be in touch, send in your queries, your observations, any kind of confusions. I'll be there, of course, for you to solve those, or different digital media. Could be, I mean, on the YouTube, certainly you can do it, but you can do it on the Zoom, or maybe in the classroom, in the Google Classroom. We're exploring all these possibilities, all these channels of exchange between you and me. So thank you very much for being with me. Stay tuned and watch out for the next class to follow. Thank you.